Assalamualaikum warahmatullahi wabarakatuh. I'm Altaf Rafadillah and today we're gonna review chemistry exam question semester 2. So here we go. For the first question, what is the electron configuration for the particle aluminum plus? So we know the electron is 13 from this question. So we need to find the electronic configuration. The electronic configuration is like 1s2, 2s2, 2p6, and more like that. So from this electron, we can say that this have a electron configuration of 1s2, 2s2, 2p6, 3s2, and 3p1. Okay, so the electron configuration from Al is 1s2, 2s2, 2p6, 3s2, and 3p1. Because there in here we have a plus, that means the electron get removed by one electron. So we just need to delete 3p1 because it have a electron of 1. So Al plus is just left by 1s2, 2s2, 2p6, and 3s2. So we can see the answer is B because it's similar to what we have done. Next, we have a question. A radioactive isotope of thallium is used to access damage in heart muscle after a heart attack. Which statement about this element is correct? Let me search it. Okay, A. This isotope has a nuclear number of 120. This is wrong because the isotope at the nuclear number is 201, not 120. Okay, B. The number of electrons in one atom of this isotope is 81. This might be correct. Let us third it. C. The number of neutrons in one atom is 201. This is wrong because this is the nuclear number, not the neutron. D. 201. This element has an isotope of uh, what we have here. This is wrong. So the right answer is B. Okay, we have the next number. In which option do all three particles have the same electronic configuration and the same number of neutrons? Okay, so we want to search the electronic configuration of this element. Let me search it for you. So the electron is 15 plus 3. So 18. This is 18 too. And this is 20. So from the electron configuration, this is wrong. So not A. Second one. Uh, let us search the electron configuration first. Hey, this is 20 because 18 plus 2 is 20. 19 plus 1 is 20. And this is also 22. Okay, this is might be the answer. But let's see these two answer. This is the electron configuration of 22. This is might be right. This is also 20. And this is 22. No, this is wrong. The last option, the electron is 22, 23, and 22. This is wrong. So the right answer is B. So from this question, we just need to analyze that we need to find the volume of hydrogen measured in room condition. So the first one that we know is we have a gram of methane and steam. So we need to find a mole of steam and methane to help us out. So we need to find the mole of CH4 or methane from from this question. This question give us that TH4 have a 0.80 gram in it, and we just for find more we just need the molarity. The molarity of TH4 is 16. This is this equation, from this equation, CH4 equals to 0.05 of mole. So, and then we need to find the mole of steam. Just like that, we need to find a mole with the same equation that we use in methane. So we know that this is 1.35. So 1.35 per H is 1, O is 16, so we have 18. The so 2 mole of H2O is equals to 0.075. If y'all done with me, y'all just can use calculator. Okay, from this we know that 0.0 1 mole equals to 0.05, 2 mole is equals to 0.075. Okay, so this is from this we know that CO2 is 0.05, and this is 0.075 times 2, 0.15 of mole, right? Then we just need to search the volume of hydrogen measured in room condition, because we already know this is 15 mole from the ratio. This is 1 per 2, and this is 1 per 4, right? So we just need to find the volume of hydrogen measured at room condition. We know how to find the volume of hydrogen measured at room condition is V equals to N times 24 mole mole PM3. So V equals the volume of hydrogen is 0.15 times 24, or equals to 3.6 dm3 square root of 3. So we just need to see the answer. The answer is not A, not C, and not D. The right answer is B. Okay, the next question is, the gas law can be summarized at this. The volume of a sample of methane is measured at room temperature of 60 Celsius, and of the pressure is 103 kilopascal, and the volume is this. So we need to search the mass of methane. We know methane is CH4, or the MR equals to 16, because C is 12 and C 12 plus 4 is 16. So we need to use the PV-nRT, or ideal gas equation, to find the gram of methane. So from this we can change the equation to PV equals to nRT. So we need to remove this, right? How do we remove RC to divide them? So set it, and this is equals to RC2. So mole equals to PV per RT. From this question, we know P equals to 103 kilopascal times the volume is 5.6 5.37 times 10 minus 3 per the room temperature is the constanta is 8.31 and the temperature is 273 plus 60 is equals to 60 300 3 and 3. So we just have to calculator and search this up. 103 times 5.37 minus 3 per 8.31 times 33. So the answer is, wait, yeah, 1, 2, 3. So the answer is 0.19987, or we can simply simplify by 2 sig fig is 0.2 of mole. So we know the mole is 0.2. Now we need to find the gram. From the stoichiometric equation, we know that N equals to ZR per mR. So if we try to find the gram, we just N times M molarity equals to gram. Okay, so the mole is 0.2 times the molarity is 16. So 0 times 16 is 3.2 gram. Let's search the answer. Okay, we find it. The right answer is D. The next question is uh, 200 cm of sample of water has an amount of oxygen gas dissolved in it. This amount of oxygen gas have a volume of 6 cm when measured at uh, 100 kilopascal and 35 Celsius. What is the idea? What is the concentration of oxygen gas in the water? You should assume that gas we have an ideal gas. We know from this question this is an ideal gas. So ideal gas use PV equals nRT. Okay, and then what we know about this? Oh, the pressure is 1 times 10 to the power of 5. And then, okay, let me think. Okay, so the volume, I think the volume of this oxygen gas is 6 6 cm3. So we need to convert it to dm. How? Oh, we just time it. Oh, we just time it with 6 times 10 to the power of negative 6, because kucing hitam dalam mobil jadi centil mondar-mandir. There is three step, there is a lot of step to take it there. 6 step. Okay, and then, well, we don't know the mole, so we skip there. And then the constanta is 8.31. The temperature is 200 273 plus 35. That equals to 308, right? So, like the other question, we just need to divide this, right? So n equals to 1 times 1 times 10 to the power of 5 times 6 times 10 to the power of 6 divided by 8.31 times 308. By using calculator, we can find the mole. Okay, let me search it for you. 1 times 10 times 6 to the power of minus 6. Uh, wait. Oh, this is equals by 2 2.344 the times of 10 uh, expo by 4 mole. Okay, we know the mole. Now we tryna search the concentration of oxygen gas in the water. So we know the concentration have a concentration equals to mole per volume of water. Okay, the mole is, we can see the 2.3 times 10 the power of 4 per. So this is from cm, right? We want to convert this to 0. So if we convert this to dm, this is to 0.2. Okay, we using calculator again. 2.3 times 10 times 10 the power of 4 per 0.2 is equals to 1.15 times 10 the power of 3. Okay, is it right? Let me search the answer. So the closest by is B. So the answer must be B, guys. Okay, because why is different? Because we use because from n we just simplify it by two significant figure. That's why this is not the accurate version, but this is still close to the answer. That's how the next question is, a sample of magnesium contains an isotope of 24 mg, 25 mg, and 26 mg only. The percentage of abundance of these are the same. The relative atomic mass, the magnesium in the sample is 24.3. What the percentage of abundance of 24 mg? Okay, so we know abundance. The equation is AR per mass times percentage, and this is gonna repeat till n per total of percentage. Ibarat we already know the AR, so 24.3 equals to 24 times 100 minus 2x plus 25 times x plus 26 times x per 100. Why this 25 and 26 is x? Because we know the percentage abundance of 25 and 26 is same. So the sisa is like 24 times 100 minus 2x, because the x is same, right? The 25 and the 26 is same, so we need to find the 24. Okay, and then we just do like this. So 2400 minus 48x, adding by 25x and plus 26x per 100 equals to 24.3. We want to delete the 100, so this is with times by 10 by 100, and this with times by 100. This is gone, and this is become 24 300 equals to 2400. It's same with this, yeah. Say x plus 25 x plus 26x. Sorry for the red writing. So this is becoming to 30 30 because we pindahin from this to this, and then uh 40 25 plus 26 is 51, right? So 48 minus 51 is 3x. So 30 x equals, yeah, so we just solve it. X equals to 10. So the answer is A, because from this equation we solve it to x equals to 10. So the percentage of abundance of 24 magnesium of 24 is A, 10%. Okay, so the next question is ammonia reacts with acid to form ammonium ion. Which row is correct? So we know how to find the VSPR shape is from the Lewis structure. So the Lewis structure of NH4 plus is N, wait, N, H, uh, H, H, H. Okay, because the H is have one electron, so X, and N we need to find 7. So to complete it, we need to 1, 2, 3, 4, 5, 6, 7. Okay, set set because this have one more electron, so this is have this. So we know this is have a 4 leg and 4 leg and no free electron because they are all connected. So the option is pyramidal. Let us search the pyramidal shape is like this. This is only have 3, not 4. So the pyramidal isn't correct. So the option is 3 or D because it have 4 and like not 3. So this is tetrahedral. But if you all remember, tetrahedral is have a 109 angel, not 106, because 106 is pyramidal. You can see in here. So the option is D. The next question: a student makes a 25 centimeter of formal DM hydrochloric acid with an equal volume of 4 dm sodium oxide. The initial temperature of both solution was 15 and the maximum was 13. The heat capacity of the final solution can assume by 4.18. The density of the solution can be assumed by 1 gram cm. Using this result, what the enthalpy change of hydrochloric acid? We know the equation for this enthalpy change is delta H, or enthalpy, equals to calor per mole. So we need to find the calor first. Okay, so the Q equals to mc delta T. Okay, okay, we know the temperature, the delta temperature is 30.15. So the answer is 15, right? The constanta is 4.18. 4.18. Okay, so the mass is uh, and the mass is because it's both have a equal volume, so the mass is 25 plus 25 or 50. So the Q equals to 50 times 4.18 times 15. That will be equals to times. I would like to show that the how can be reduced. 331 300 3,135 joule. 135 joule. Okay, we want to convert it into kilojoule because enthalpy change is used in kilojoules, right? So is equals to 3.5.7 kilojoules. Okay, and then we need to find the mole. Okay, so how do we find the mole? Like other, we use N equals to GR per MR or molarity. Okay. Um, or we can use another type, that's not this, that equals to you know when I say that C equals to N type V. Now we can search the mole using N e equals to volume times concentration. So we know the volume is 25, right? So we want to convert it into a dm. So 25 times 10 minus 3 times 4. So the mole is 25 times minus 3 times 4 equals to 0.1. So the mole of hydrochloric acid is 0.1. After that, we can search the enthalpy change by the data we have collected. The enthalpy change equals to 3.157 times 0.1 or equals to 1.31.57. The most accurate one is B. 35. Sorry, guys. Times 3.135. We can simplify to 31.35. So the most accurate one is B, because we just need to convert it into to sig fig to 31.4. That means the answer is B. Okay. Okay. We have a question that search for the standard enthalpy change of combustion of ethane. We know ethane is 3 carbon 2 hydrogen 6. So because this is a enthalpy change of combustion, we need to add oxygen gas, and then we need to make a reaction. So the reaction is obviously is a CO2 and and H2O or water. Now we need to setara in, or we need to make that equilibrium. Okay, so the first step is we need to check the C2. Is the C2 is already correct or not? So we have two C in here, but only one. So we adding two in here, right? Set. But the O2 is not fulfilled. This is becoming 4, and this is or becoming 5. And then, but I think we need to skip the O2 because this is a kind of a tricky part. Okay, then we have a uh, 6H2O, and this is have 2. No, we have a 3, and then this is become equilibrium. C2 have an here, and here have a 6H, but the O2 is still have a still have a not right amount. So we just need to calculate the total of the O2. So the total is 2 O2, and this is have a 4 oxygen, and this is have a 3 oxygen. So the total is 7. But if 7 times 2 is 14, we need to cancel out the 2. We just add the 2 in here. Okay, we have already make uh, equa the equation for an enthalpy change of combustion of ethane. Now we're trying to calculate the carbon and hydrogen for this. Okay, uh, because we already know in here we have 2 carbon, and we know the delta H in this. We can search by delta H equals to delta delta H product minus delta H reactant. Okay, we know this, right? So we just need to put the product and the reaction for make it better. So the product is CO2, right? So so we need to find the uh, product of CO2. There is a carbon in here, so and there is a 2 of CO2. So 2 times 3 minus 3 394, and then we're adding the 3H2O. So 3 times 286, and then we uh kurangin with 140 because there is a ethane here. Means 140. Okay. After this, we can use a calculator to find the enthalpy change. So we just put it 2 times 194 and 94 plus 3 times minus 286 plus 140. So the answer is from this is 100 minus 1506 kg mole. So the answer is B. Okay, so we want to search this question using a Hess law. What is Hess law? Hess law is that energy cannot be created or destroyed, so it can be transferred but cannot be destroyed or created. Now we want to search the standard enthalpy change formation from methanol. We know this is methanol, right? So we need to make a question for the formation of ethanol. So this is just we make C plus O plus H. There is a H is 2 and O2, and this is only 1, right? So because the O is only 1, so we put it 1 per 2, and H is 4, right? So we just put it in here. So the enthalpy change formation, the equation is this, all right? Then we want to search the enthalpies. We want to search about how do we make this kind of. We know that enthalpy change or formation, enthalpy change, it cannot be destroyed or created from Hess law, right? So we just do we just like like this is same, right? This is the from this, and this is same, right? But when we like mirror the equation, it's become 7 to 6, and CO become in here, and plus H. Like we just like mirror it to can we find the enthalpy change. Okay, so to fulfill this, we don't need to mirror this equation because we want to th in here, right? So this is stay the same. Okay, but we wanna delete the H2O. Okay, so this is we balik, we mirror to 286, and then the H2O will in here, then we times it 2 for this is to be deleted, right? So for right now is 27 296 to 8 286 times 2 is 572, right? Okay, and then we just need to uh have a lot of things like this is because this is already got mirror, we can delete this, right? So this is and we need to mirror this also because we wanna delete the CO2. Okay, set, and this is becoming a 394, not minus, because we change it the CO2 in here. So the total is just like uh the total is mhm, uh 394 plus, because this is already becoming this is not ah because the our still negative, right? And then we want to make this positive, and negative is becoming positive, and this is right also because we already know this is the H2O we need to times 2 because we need to remove it in here. So the answer is must be D. Okay, test. Okay, let's back to the next question. Attain C2H2 completely combust as shown in the question. Using the average bond enthalpy interval, what is the enthalpy change of combustion of ethane? We already know, like question is this, using delta H equals to delta H product product minus reactant, or delta H reactant. I'm sorry, reactant, right? Okay, we already know that this is created by that, right? So we just need to find this. Okay, so H, this one, this is a 14, and this is 1 equals to CNC 84, and this is same like CH bond, so this is 14 410. So and this is we can uh we can we already know this is where this is for 496, um um because of that this is a 2 times half, so this is 2.5. So we just need to calculate for the H fraction, right? So the total is for 410 times 2, adding plus 840, and plus 2.5 times 496. Using calculator, we're gonna have a answer that wait, yeah, let me calculate first. times 2 plus 8 103 answers 2.5 times 496. So the total in here is 2,000 and 80,070. Okay, and then we need to find the product is H2O and 2CO2. The H2O is it's like O, H, and H, right? So we in here we have a double bond of this, right? Because in here and here, so this is a 460 times 2, and CO2 is O, C, and O. Because it's double, it become double, right? O, O, CO, and CO. So because it's times 2, and then this is because of 4, it's become 4. So this is uh C 740 times 4. Okay, then we need to add them. So using a calculator, 460 times 2 added by 740 times 4 is equals to 3,880, right? From this equation, we know when the equation is 3,800 minus 2,870. Okay, now we calculate it. The answer is 1,010. Let us see. I think I have miscalculated here. This is not 270, but 200 and 9,000. So the answer is and we need to search enthalpy combustion. So we need to see the reaction, right? Because we want to find the delta X reaction. So delta HR equals to delta HP kurang lain and delta H biasa kan set. Okay, so we want to search it like 2,000 2,900 minus 3,080 and 80, and then this is equals to minus 200 and 980. So the answer is A.